Okay, so today we will be going over the basics of, if you guys will give me a minute. Sorry, I have to see this. So today we will be going over the basics of stars. Okay. Yes, stars. So, what are stars made of? As you can see, they aren't made of gas. They're made of something called plasma. This is commonly referred to as the fourth state of matter. And what you probably don't know is that this is the most abundant form of matter in the universe. 99% of all matter is made up of plasma. But in order to understand what plasma is, we need to understand atoms. I don't know how many of you know what it is, but I'm not going to risk anything. So we're just going to go over it. We have to start at the very basics. So what are atoms? If you see in this diagram over here, they are essentially just have a nucleus over here composed of protons, which are displayed in red, and neutrons, which are in green. They have electrons orbiting the nucleus at various energy levels, if you will. That's the simplest way to put it. So yeah. And the thing is, electrons have their own charge. It's a negative charge. So electrons carry a negative charge, and they are attracted to the protons in the nucleus, which carry a positive charge. Okay. Does everyone got that? Okay, yeah. So moving on. What is plasma? In order to create plasma, you have to take gas and heat it to the point of it changing into a state of matter. Changing matter, really. The atoms and the electrons split apart. So it's so hot that the electrons aren't bound to the nucleus anymore, because if you will recall, electrons are negatively charged and the protons are positively charged. Opposite charges attract, so the electrons are attracted to the nucleus in that way and are bound. They can be pulled away from it and carry energy to other places. That's how we get electricity. But what you need to know for plasma is that there's so much there that what happens is that the nuclei themselves split apart, and the electrons are therefore pulled away from the nucleus, and they just whiz around at speeds beyond comprehension. The average temperature of plasma is much higher than anything you can do on Earth, and this is a source of constant energy provided you have enough power. So, what are stars? How do they form? Excuse me, give me a minute. Sorry about that. Anyway, so stars form via something called an accretion disk. Now, this is just a disk of dust and gas orbiting just any central area. And orbiting means spinning around something. Okay. Does everyone understand me so far? Everyone needs to say yes.
I can understand what's accretion disk.
Yeah, I'll go over it now. So let's go back to it. So an accretion disk is a disk of dust and gas orbiting a central area. And the faster they orbit, they begin to collide into each other and begin to clump together in various areas. Okay. And as the clumps get larger, they gain gravity. Okay. Because anything with mass has gravity. It's a law of nature. So the more mass you have, the greater your gravity is, to put it simply. And if those clumps get big enough, they ignite, because the gravity forces the atoms to start fusing together, and that's how a star is born. This is also how planets form, just minus the whole igniting part. Is everyone clear on this so far?
Yes. Yeah.
Good. Okay, moving on. Now, I'm going to focus specifically on the sun today. In coming classes, we will go over other stars. Okay. So the sun has an outer layer called the corona, which you can see in this general area here. The word itself means crown in Latin, and the simplest way to think of it is the sun's atmosphere, just a very hot atmosphere. The chromosphere is here, and it is basically the skin of the sun. And this has a temperature between 4,000 degrees Celsius to 10,000 degrees Celsius, and it is 2,000 kilometers thick. Just to give you some, there is really no comprehension I can give you for this. It's a very big object. Just below those 2,000 kilometers is the photosphere. This is the only visible surface of the sun. It's actually pretty cold by sun standards. It's only 6,700 degrees Celsius, and it's the only layer that emits sunlight from in what we perceive as sunlight anyway.
Okay.
So is everyone following me currently?
Yeah.
Yeah.
Yes.
Now I'm here.
Okay. So yeah. And going further into the sun, you will find the convection zone. Now, this is called the convection zone because the material in it undergoes a convection cycle, if you will. The hotter material rises up from the lower regions of the convection zone, and the colder material falls to the inner regions. That's basically how convection works. It's how your to put it simply, it's how your AC generators work. Does everyone know? So everyone is sitting in a room, right? I'm gonna assume, or some room.
Yeah.
Yes.
In those rooms, sometimes when you do, some of you guys might have like an AC machine. You know how there's like a fan and there's an AC machine next to that?
Yeah.
Yeah.
Yeah, that gives out cold air, and that cold air falls down. That's convection. If something is colder, it goes to the ground. Something is hotter, it rises up. I'm going to request everyone to be on mute if they aren't speaking at the moment. Thank you. Anyway, moving on. So this movement of material, it creates solar flares and sunspots. We don't need to know about those right now, although if anybody wants, I will explain those in a later date. Moving on. We got the radiative zone. This is just outside the core of the sun, temperature of 7 million degrees Celsius. 7 million.
What is radiator zone?
Basically, it's where most of the sun's energy comes. It's what radiates most of the sun's energy. All you need to know, though, is that it's just outside the core, and it has a temperature of 7 million degrees Celsius. And just take some time to process that if you need to, because that's a very big number. At that sort of temperature, to be honest, metals would not be liquid, they'd be gas. So think of that what you will. But one interesting thing to know is that this area is so dense that particles, any particles emitted here, can take 50 million years to get through this entire area. Which, again, if you need to take some time to process it, feel free. Anyway, moving on to the core. This is the hottest part of the sun, 27 million degrees Celsius. I'm not even going to bother converting that into Fahrenheit because at that point, the numbers stop making sense. Now, here, nuclear fusion occurs, and this is really the power source of the sun. Energy emitted from the core can take millions upon millions of years to escape the sun as photons. It's that powerful. Like, that's how dense the sun is. And the area is so hot, electrons don't even orbit the atoms. They just move around in random directions. So, are we ready to move on?
Yeah.
Okay.
Yeah.
I have to explain nuclear fusion now. Now, I'm not going to go into detail, but please just don't ask too many questions. This is very complex. It's essentially, it's when the nuclei of two atoms combine to make one bigger nuclei. So to put that into context, has anyone here been modeled with clay before?
Yes, I have.
But everyone
Yeah,
has
I do.
an idea, right? Or let me put it this way.
What?
Sorry?
Okay, let's use a different analogy. Take two half cups of water. Okay.
Okay.
So if you pour them into one cup, you'll get more water, right? You'll get more water. That's
Yeah.
essentially how nuclear fusion works. You take two smaller nuclei, you combine them, you get a bigger nuclei. Okay, does that make sense?
Yeah, I've
Makes
studied it
sense.
before.
Yeah. Now, in any star, regardless of which one you take, the sun, Sirius, Betelgeuse, this happens millions of times a second. And this releases a lot of energy, like a lot. This diagram here is a very loose example, but suffice it to say what happens. Atoms combine, big explosion, you get another atom, a lot of energy, and some leftovers. This is a more complex diagram over here, but don't worry, you don't need to understand any of it. Okay. So is everyone clear so far?
Yeah.
Yeah.
Good. Now, here's the thing though. If you remember back to the accretion disk, I say that as the clumps got bigger, they gain gravity, correct? You guys remember that?
Yeah.
So
Yes.
so going back to the accretion disk, it's just a law of the universe that anything that gains mass or anything with mass has gravity, which means that everybody sitting here and the computers that you're using or the phones that you're using to watch this presentation, everything has gravity. That's just final. You cannot change that. The Earth has gravity. Jupiter has its own gravity. And the amount of gravity, and like the gravity something has, increases.
Actually, Jupiter have more gravity, right?
Yes, because it has much more mass than Earth, meaning that gravity increases exponentially with the increase in mass. But with the sun is millions of times heavier than Earth, has much more mass. But the thing is, with that,
I've heard that if it's increase of mass, it's even increase of size.
yeah, that's true. But the thing is, see, look, with that logic, the gravity that the star attains, it should make it just implode. The star's own gravity should crush it. That's nuclear fusion. Oh,
Okay.
wait, hang on a minute. Give me a minute. I apologize for this. So, Nishka, can you hear me?
Yeah, I can hear you.
Nishka.
Your voice is breaking in the middle, so I can't understand everything fully. But sometimes I can understand. Sometimes your voice is just breaking in the middle.
Okay, I think you may have an internet connection problem on your end. Just read the presentation. Most of the information you need will be there, okay?
Thanks.
No problem. Okay, so yeah, nuclear fusion prevents gravity from crushing the star. Fusion acts as an outward force to prevent the star from collapsing in on itself for gravity. That is basically what gravity is. Gravity is an inward force. Nuclear fusion is an outward force. That's what stars exist constantly. They exist on a knife edge, the point where gravity and fusion are balanced. Okay, I will go over when one wins over the other in the next class. But the thing is, for fusion, you need fuel. Now, this is probably confusing to most people, but stars have different stages of fusion just to prevent them from collapsing. The stages of nuclear fusion, like I said, this is only applying to our sun, nothing else, because otherwise you'll be very confused. So everything that I've mentioned happens in the core of the star. Okay. Other stars, it gets more complex because they have either more mass or less mass. Bear with me. So stage one, what our sun is currently doing. This is referred to as the main sequence. And here, hydrogen is being fused into helium. Complex process, I'm not going to go into detail. Okay, all you need to know is that the hydrogen atom, multiple hydrogen atom nuclei are fused together to create helium. Okay, stage two, this only occurs if all hydrogen has been fused into helium. Okay, and what happens is that when you're fusing bigger nuclei, you need more energy. You need more mass and stuff. So if you had, it works like this. You have 2 cups of water. The more water there is in them, you have to exert more energy to pour them into one bigger cup, right?
Yes.
Okay, that's basically what a star does. In order to meet the requirements to fuse helium into carbon, what it does is it actually increases in size massively. I mean massively. This picture here should give you a sense of scale. So you guys remember from my last class what 1 AU is? Does everyone remember? Can anyone tell me what 1 AU is?
1 astronomical unit.
How long is 1 astronomical unit? Does anyone remember?
Light year?
Nope, that's too long. Okay, so 1 AU is the distance between Earth and Sun. Okay. Now, currently the Sun has a diameter of 0.01 AU. Still big, but the thing is, once it starts fusing helium into carbon, it becomes what's known as a red giant, which you can see here. It swells in size to 2 AU. Its diameter is double the length of the distance between Earth and Sun. And yes, Earth will be incinerated, but that's going to happen in a very long time from now, so don't worry. But that's all the Sun can do before it dies. I'm not going to go into detail about that. We will worry about that another time, okay? Probably next. But anyway, I've told you everything you guys need to know. So we will have a quiz, right? And today, I'm actually going to be scoring you guys. You will all get a score. So just before we continue, I will up.
How we'll get to know the score?
I'll tell you at the end. Okay, so is everyone ready?
Yeah.
Question 1, what are stars made of? Type your answer in a private chat to me, or just, yeah, private chat. Good job, Naveen. Good job, Arnav. You are correct, as well as Ditya. So, good job, Parnika. Good job, Giridharan. Good job, Nishika. Arden, I am still waiting on an answer for you. Okay, so 3, 2, 1, time is up. Stars are made, oh wait, from plasma, sorry. Who said B? Naveen? Sorry,
Yeah.
sorry, I didn't read properly, sorry, but Naveen, you are wrong. Anyway, so to everyone who said plasma, good job. Like I said, it's superheated gas, not gas. Question 2, what is plasma? I want you guys to type your answers in a private chat. Okay, Ditya, I will accept the answer. Good job. Arnav, Arnav and Naveen, try again. Arnav is, you need to work on the answer. It's not correct. Okay, Parnika, I will accept the answer. Naveen, please try again. Arnav, please try again. Giridharan, that's not wrong, but it's not fully correct either, if you understand. Asim, well, you're gonna have to be more specific than that. Okay, Nishika, yes, you are technically correct. Giridharan, you have to sort of combine your other two answers and you have to be a little more creative. I will reveal the answers in 3, 2, 1. It's a soup of nuclei and delocalized electrons. That's the specific. Aryan, you're not 100% correct, sorry. But I will accept the fourth state of matter, not math. And heated gas that is no longer gas. I'm going to accept that because that's the way I described it. Okay. So is everyone clear?
Yes.
Arnav, you are correct, but I'm not going to give you the point because you ran out of time. Sorry. Question 3. What is an accretion disk? You got your choices. I need a private chat answer. Giridharan, please try again. Nishika, Ditya, good job. Both of you have done it well. Arnav, please try again. Well, sorry, Naveen, you're not technically wrong, but you're gonna have to. I'm not gonna accept that.
I didn't hear you. Can you please? Did you check my answer?
Yes.
You didn't hear
Nishika,
me.
good job. Ditya, good job. Both of you have done well.
Me?
Thank you.
Did my answer is correct?
No, Naveen, you're gonna have to try again. Giridharan, good job, but you're not getting the point because that's your second guess. Barnika, good job. Naveen, where is your name? Well, you're correct now, but I'm not going to give the point because that's your second.
Am I correct?
Who asked that? Could you repeat the question?
Arnav.
Yeah, good job. You've done well. That was your first guess, wasn't it? Yeah, Arnav, you've done well. Good job. So 3, 2, 1. Time is up. The answer is B. It's a disk of dust and gas. Now, to everyone who said a disk of asteroids, you're not wrong, but at the same time, it's not correct because asteroids come after the accretion disk. Does that make sense?
Yes. It does.
Question 3. What is the name of the outermost layer of the sun and what is the translation of the answer? And if anyone uses Google Translate, well, you're wrong. Naveen, that's partially right. What is the second part of the answer? Anishka, you're gonna have to try again. Giridharan, you're gonna have to. Oh wait, sorry. Anishka, try again. Giridharan, you're partially correct. I need the translation. Arnav, I'm afraid that is not correct. You're gonna have to try again. Ditya, good job. That is 100% correct.
I'm sorry, I got the spelling wrong.
Parnika, you're gonna try again. I'm not giving you the point there. Nishika, you are correct. You are partially correct. I need the translation. Giridharan, try again. Need translation as well. Aryan, you are correct, but I need the translation. This is not English.
What do you mean by this Okay, I got it.
Arnav, what is the translation? I'm not saying that choice is wrong. Parnika, your choice is correct, but I need the English translation. Nishka, yes, you are getting the point. Parnika, I need the translation, but I doubt I'll give you the point because that's your second. Giridharan, no. Sorry. Aryan, if you want, Aryan, I need the translation, otherwise you're not getting the point. Parnika, you are correct.
I don't know.
Naveen, well, yes, Naveen, it is a part of the sun, but I need you to give me an option and translation. This was a bit of a trick. This was a bit of a cheap question, if you will. I will admit that, but great.
Hello. I want to know what do you mean by the translation?
Well, the word isn't in English. It's in a different language. I need the English translation of that language. So, like, you know how when you say bonjour in French, it means hello in English?
Yeah.
This word means in English. I'm not going to say the answer. No, sorry. Okay, 3, 2, 1. C, and it's crown. It's corona. That's Latin for crown. Okay. Arnav, you are correct, technically, so is Parnika, but you didn't give me the translation. Aryan, why have you given me a... Okay.
I gave it to you before, like in Latin it means crown. I meant corona, but accident I pressed V.
Okay, fine, I'll give you the point. You were correct on the translation after all. Question 5. What is the temperature range of the chromosphere specifically? Oh, whoa. You know what? Nobody... Did anyone see that?
Yeah.
I couldn't see it.
Well,
What
I saw
to
that
see?
also.
Actually, I was typing the answer in your chat box.
Okay, everyone just give me an answer to this because something weird happened. Aryan, please try again. Ditya, good job. Giridharan, good job. Nishika, please try again. Naveen, good job. Where is it? Thank you. Good job. Oh, wait, hang on. Nishika, you are not getting the point even if you get it correct because second guesses and stuff. Naveen, you are correct. I need more options, people. We are running out of time. Parnika, good job. Arnav, good job. Where is your... Thank you, thank you. Aryan, please try again. Okay. 3, 2, 1. Thumbs up. Everyone who answered C, 4,000 degrees to 10,000 degrees, good job. Question 6. What is the visible layer of the sun and which layer is below that? I need both for you to get the point. And like it says, type your answer in a private chat. Naveen, you're gonna have to try again. It's not. That's a star's life cycle stage, not the layer of the sun. Yes, good job, Parnika. You are 100% correct. I'm impressed, actually. Ditya, you're gonna have to try again. You're only half right. I'm not gonna tell you which half though. Yes, I am mean. You guys can keep on shouting at me. Ditya, you got the wrong half. That's not correct. Arnav, please try again. Arnav, you have to try again. I'm going to wait another minute before I give you guys the solution. So far, as far as I can, only one person. Oh, Nishka, Aryan, please try again. Nishika, which part did you not hear? Yeah, Arnav, that part is correct. Ditya, no, sorry. You gotta try again.
I did not hear that bit. I did not hear the bit of the sun's layers. So.
I can't give you the point.
Even me, I was continuing.
Okay, I'm just letting you know.
Okay, got it. You'll get the answer shortly. Ditya, you are going to have to try again. I'm going to reveal the answer in 5, 4, 3, 2, 1. Okay, Arnav, you're getting the point because I haven't changed the slide yet. It is actually, Arnav, I have to take that point away. It's the photosphere and convection zone for anyone who's concerned.
Will I get half point for half of the answer or no marks?
No.
Have I got the full point or the half?
It's either 1 or 0 points. I can't give half points. I mean, I would, but I haven't got a proper system. So
Okay, no problem.
I'll confuse myself if I do. What is nuclear fusion? You guys decide. I need an answer. Aryan, Nishika, good job. You guys get the point.
My answer is correct.
Who? Aryan, yes, your answer is correct. Nishika, your answer is correct. Giridharan, your answer is correct. Ditya, you are correct.
My answer is correct.
Naveen, yes, you are correct. Arnav, you are correct. You get that point that you lost back. Who else are we waiting on?
Hello?
Yes, you are correct, Arnav. Don't worry.
Yeah, thanks.
This one is pretty obvious, if I'm honest. I didn't know what else to say for this. Parnika, sadly, that is not correct. I will have to not give you that mark. Seeing as everyone.
I think, but doesn't it mean like two like nuclei like they combine to make a bigger one?
Yes, meaning that the answer is C. That's what it means, fusing atoms, because atoms have a nuclei, so you fuse them together. That's nuclear fusion. You don't get the point because, like I said, it's not fusing, it's not combining nukes. By nukes, I mean nuclear warheads, atomic bombs and stuff. Anyway, gravity crushed a star to nothingness. What force prevents that? I need an answer in a private chat. Giridharan, what?
I did not understand the question.
See, look, gravity is everything with mass has gravity, correct? Now, gravity is an inward force, and everything with gravity should be crushed. But especially stars, given how big they are, something prevents that. What is it? Aryan, you're gonna have to elaborate. Aryan, just to give you a hint, I'll give you a hint.
Do you mean what? How does it prevent from? What does it prevent from collapsing?
Yes, that is it. What is that force? Or what is the thing? I need the. Okay, well, sorry I didn't warn you guys, but the answer is nuclear fusion. Sorry I didn't give you guys too much time. I'm not going to give anyone the point. Aryan, that was just a little too late. I apologize. Question 9. What is happening in the sun's core now, like right now? You guys have your options. Naveen, you get another point.
What?
You're correct. You get another point, man. Ditya, you are correct. Good job. Aryan, you are correct. Nishika, you are correct. Was your number there?
Is my answer correct?
Ditya, yes, yes. Don't worry, you're fine.
Okay.
I'm waiting on some answers, people. Yes, Giridharan, good job. You are correct. So are you, Arnav. Good job.
What?
Arnav, you're correct. Good job.
Thanks.
Anyway, who else are we waiting on? Parnika, I can't give you the point. Sorry, try again. Okay, I'm giving you guys 10 seconds from now. Parnika, we're gonna try again now. 3, 2, 1. Time's up, everyone. Answer is C. You can see the very extended version of it here, but I'm not going to go. Question 10. Last question. How big will our sun grow before dying and why? This will give you, so if you get one of these correct, then I'll give you a point. If you get both of them correct, you get 2 points. Let's see.
How big will the sun?
Irido, and you're gonna have to try. I can't accept that answer. I'm not gonna. Naveen, you have to say. Okay. How big will our sun grow before dying? Answer that part first, then give me the second. Then give me the second answer. Naveen, I'm not gonna accept the answer for. Okay, Nishka, that is correct. Yes, I know, Giridharan. Why would I tell you? This is my quiz. You have to tell me. No, I'm not telling you.
I can't hear you.
Naveen, dear, I mean, partially right, but not really. No problem, Giridharan. Don't worry, that's not going to count as your answer, but anyway. Nishka, you get 1 point. I need a second answer. See if you can give it to me. How big will the sun grow?
One second, I'm writing the answer.
Large. Arnav, I mean, that's vague. So, no, I guess. You have to try again, man. Dita, you get 1 point. How bigger?
You need a particular size?
Yes, I need the size specifically.
My answer is correct.
Not really, per se. That's, I mean, currently it's bigger than Earth, but it's not about to die. Let me put it that way. You're gonna have to try again.
So it's wrong.
Okay, Ditya, how big is that? Aryan, you're gonna have to try again, but you're closest so far. Parnika, you are very close, but I'm typing a question to you in chat just to lead you along. Aryan, you have to try again. Ditya, that is what it is, but I need the size of that. If I say it, it'll probably give the answer.
1 second, I'm trying it.
I'm not gonna give the answer away yet. Nishika, just guess. Just take a wild guess, okay? It doesn't really matter.
Unit or university?
Unit. Aryan, Nishka, you are getting closer, but bigger number. That's what I'm gonna say. Bigger number. Parnika, I will give you the mark. It's not 100% correct, but given what I've told you, it's not 100% wrong either. Arnav, it will. Nishka, that's too big a number, but Arnav, how big will the sun get? Naveen, no. You have to. Aryan, your number needs to be a little bigger. Nishka, your number needs to be a little smaller. Naveen, you have to try again. This is okay. You guys get another 20 seconds. Otherwise, I am just showing the answer.
What about me? Am I right or wrong?
You've only got one. Wait, hang on, let me just see. Just type your answers in again. I can't see them.
Yeah.
Let me see if you got both. Nishka. Yeah. Okay, Parnika, you are getting it. Good job. Yes.
I typed it.
Good job. Yes, both of you. Good job.
Am I right?
Yes. Okay, Nishka, the number is still a bit too big. 3, 2, 1, time's up. I'm done. 2AU. So Nishka, for your reference, that's 200 times as big. Because it needs to fuse helium into carbon, which means nuclear fusion. So whoever said that, they get the mark. Okay. Now, that's it for this presentation. I'm going to stop screen sharing now. And so, we get a drum roll so I can reveal the winner. Anyone want to give me a drum roll? No one's going to give me a drum roll. So, go on, play along. Okay, moving on. Okay, the winner of this quiz is Ditya. Good job. 9 out of 11. Second, Parnika. 8 out of 11. Third, Nishika. 7 out of 11.
You know what is my mark?
Arnav, you got 4.
Not no, Naveen.
Aryan, you got 2. Naveen, you got 3. Aryan, what is it? Okay. Yes, Arnav. Okay, so Arnav, you got 4. Nishka, you're third. So you guys already know the answers. So I think that should be. I'm just trying to think. Is there anything else I need to do? Just give me a minute. Okay, so we are accepting donations. So if you guys, Giridharan, just so you know, you got 4 out of 11. So every mark I'm giving everyone right now out of 11. Okay, so I'll repeat it for reference. Ditya, you're 9. Giridharan, 4. Parnika, 8. Arnav, 4. Nishika, 7. Arin, 2. Naveen, 3. If you guys are feeling bad about your scores, don't be. This is a very confusing subject. I'm honestly amazed everyone got some points, to be honest. So don't feel bad. Nobody feel bad, okay? But yeah, so I've got everything written down. So just a reminder, we are accepting donations. If you guys want to give any donations, it's available on the website. And remember, there is a YouTube channel, so that if anyone is confused on anything or they need to go look over something, go to the YouTube channel and check. Subscribe to the YouTube channel as well, because you need to. Oh, and if anyone has any like artworks or poetry or anything they did for this class, email it to the quarantine learning group. Okay. So if there's any like special artwork or something that you guys have that you want to send to us, email it to the quarantine learning group. And as far as I can tell, that's it. So thank you all for coming. Have fun, stay safe, and yeah, that's about it. Goodbye, I guess.